Okay, Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So today we will continue our course MAT522 with chapter 2. In chapter 1 we already seen about the introduction to differential equation. Okay, so we learn about what is differential equations, where differential equation is the equation that consists of the derivative of a function. Okay, so kalau kita ada derivative dy dx of a function, so for example dy dx lah. Okay, so variable dia boleh jadi apa-apa variable. We have two variable in the differential equation, which is dependent variable on the numerator and the independent variable in the denominator. Okay, so we also learn on how to classify our differential equation into a few category, which are types. Okay, we have ordinary differential equation and partial differential equations, and then we categorize our differential equation according to the order of the differential equation, where the order of differential equation is the highest derivative appear in our differential equations. And then we categorize our differential equation according to the degree, where the degree is the power of the highest derivative appear. And the last one, we learn on how to categorize our differential equation according to linearity. So we have either linear differential equation or non-linear differential equation. For linear differential equation, you need to fulfill all the three condition. The first one is there is the only the function and the derivative at degree 1 only. Okay, and then the dependent variable and its derivative only have degree 1, the first condition. And then the second condition is there is no product between the dependent variable and also its derivative. Okay, and the third condition is there is no non-linear function of dependent variable. So kita dah tengok macam mana kita nak kenal pasti either our differential equation is linear or non-linear. And then we also go sekali imbas tentang the solution of differential equation, how to verify the solution of our differential equation, where we need to prove that the left hand side is equal to the right hand side. Okay, and we know that our solution of differential equation is when we go back, we do the antiderivative process, where we go back to the original function y, and we also have two types of solution that we go through, which is the particular solution and general solution. Okay, so we will go through into details in chapter 2 onwards. So in chapter 2, we will go further to our first order differential equation. As mentioned before, in our course we will focus on the ordinary differential equations only. Okay, so in chapter 2 we will go to the first order differential equations. So when we are talking about first order differential equation, you need to understand that our differential equation is only at first derivative because it's first order. Okay, so it's involved only first derivative of differential equations. Okay, so in chapter 2 it only involves first derivative of differential equations. So the first one we want to see about the separable differential equation. So what is said to be a separable differential equation? We consider a class of first order differential equation of the form dy dx equal to fxy. Okay, so kita consider kita ada differential equation ni adalah satu function fxy, ni adalah function of x and y. Okay, and the first thing that you need to understand and is very important is to recognize which one is the dependent variable and which one is the independent variable. So in our differential equations, we need to understand that the variable that is in the numerator, this one is the dependent variable, and the one in the denominator is independent variable. Okay, and we read this one as the derivative of y with respect to x, means that all the function here have been differentiated with respect to x, and then we have all the differential equation here. So equation 1, this equation is considered to be separable if it can be written in the form of hy dy equal to gx dx. Okay, so if you can see here, the function of y with dy and the function of x sit with dx in the different side. This one is the left hand side and this one is on the right hand side. So if we can separate our function of y with dy and our function of x with dx, we call all of this as a separable differential equation. Okay, so kalau you tengok dekat left hand side kita ada dependent variable dengan its derivative. Dekat right hand side kita ada all the function with independent variable and its derivative. That's why you need to understand which one is dependent variable and which one is independent variable. Okay, so to make it more clear, let's see one example, a few example here. So here you have the differential equation. The first one, x cubed plus y plus 1 to the power of 2 dy dx equal to 0. First of all, why this one is called as a differential equation? Because you have the derivative inside your equation. That's why we call all of this equation as differential equation. Okay, the second one, why we call this one as first order differential equation? So if you see here, our derivative, the highest power of our derivative here is 1. Therefore, this one is the first order, order 1. Okay, differential equation kita ni order 1 kerana derivative tertinggi yang appear dalam differential equation ini adalah 1. Okay, now we want to check either our differential equation is separable equation or not. So we need to separate the dependent variable and its derivative on one side and the independent variable with its derivative on the other side. So we need to remove, or we need to move the variable one by one. Let's say which one we can move here. So the first one you can move here is x cubed. It's positive x cubed. You can move it to the right hand side, it will be negative. So you write it first. Okay, so you will have y plus 1 to the power of 2 dy over dx is equal to negative x cubed. Okay, and then you know that the dependent variable must sit with its derivative and the independent variable must sit with its own derivative. Therefore, we see we can move the division of dx. Bahagi dx, move to the right, it will be darab. Okay, bahagi move kepada right, kita akan dapat darab. Therefore, what you have here is y plus 1 square dy is equal to negative x cubed dx. So if you see here, your dependent variable now already sit with its derivative on the left hand side, and your independent variable also sit with its own derivative on the right hand side. Therefore, this one is the separable equation. Okay, so it's easier. So now we want to see the second example here, 2xt dx dt minus negative x square minus t square. So here is your dependent variable and here is your independent variable. Means that t must sit with dt, x must sit with dx on the different side. Okay, so now we want to try to move. What you want to move first? So let's say you want to move negative x squared to the left because you see the derivative is here, so you want to move it to the left. So it will be 2xt dx over dt plus, okay, minus, move to the left, it will be plus x squared equal to negative t squared. Okay, class. So now you want to move t. Okay, you want to move dt. Let's say this one is darab dt. This one is bahagi dt. So kalau kita nak hilangkan bahagi dt, sebenarnya konsep dia adalah kita kena darab dengan dt. Okay, barulah dia boleh hilang. So bila kita darab dengan dt dekat sini, semua term kita kena darab dengan dt. Ini pun kita kena darab dengan dt, yang ini pun kita kena darab dengan dt. Okay, so dt dekat sini dah hilang. So yang tinggal adalah 2xt dx tambah x square dt equal to negative t square dt. So if you see here, you cannot separate because here is still have dt with x square, cannot, because dt must sit with its term t. You see here also have t with dx. Okay, so this is the example of non-separable equation. We cannot separate this equation. If you want to do, let's say, doktor tak payahlah remove negative x square, kita remove this one to the right. Kita boleh try. Okay, so ini adalah bahagi dt, kita move ke right, dia akan jadi darab. So apa yang tinggal dekat sebelah kiri adalah 2xt dx equal to negative x square minus t square dt. So if you can see here, dengan dx masih ada t, dengan dt masih ada x. Tak boleh. Okay, x mesti dengan dx, t mesti dengan dt di bahagian yang berbeza. Okay, so ini adalah example of non-separable equation. Okay, let's see the third one here. You have x dy dx equal to y minus 1, y plus 1 minus y. Okay, so kita buat satu-satu. Mula-mula kita pindahkan. Okay, so you tengok ni semua y. Betul? So kita boleh pindahkan semua sekali pergi ke sebelah ni. Okey, macam mana nak pindah? Yang pertama, awak kena samakan penyebut dia dulu. Sebab ini ada negatif y kan. So tak nak bagi keliru, kita samakan dulu penyebut. Dia akan jadi x dy over dx equal to y minus 1. Okay, y minus 1 bahagi y plus 1 tolak y darab y plus 1 bahagi y plus 1. Okay, so sekarang dia dah sama penyebut, dia jadi x dy over dx sama dengan y minus 1 minus y darab y plus 1 bahagi dengan y plus 1. Okay, so kita boleh remove satu-satu. Okay, mula-mula kita remove bahagi y plus 1 pergi sebelah, dia jadi darab. So kita ada y plus 1 darab dengan x dy over dx equal to y minus 1 minus y darab y plus 1. Okay, lepas tu kita remove darab x pergi sebelah jadi bahagi. Betul? Darab x pergi sebelah jadi bahagi. Ataupun paling senang adalah kalau you tengok dekat sini, paling senang adalah kalau kita nak remove pecahan. Okay, so kita ada pecahan dekat sini, kita remove pecahan pergi sebelah, dia akan jadi terbalik lah kan. Yang bawah duduk atas, yang atas duduk bawah. So we remove all the pecahan here, pergi sebelah, dia akan jadi terbalik. Dia akan jadi y plus 1 bahagi dengan y minus 1 tolak y darab y plus 1. Darab dengan x dy over dx equal to 1 kat sini. Okay, and then kita pindahkan darab x pergi sebelah, dia akan jadi bahagi. So kita ada y plus 1 bahagi dengan y tolak 1 tolak y darab y plus 1 dy over dx equal to 1 over x. And then kita pindahkan bahagi dx pergi sebelah, dia jadi darab. So apa yang kita ada kat sini adalah y plus 1 bahagi dengan y minus 1 minus y darab y plus 1 dy equal to 1 over x dx. Okay, so kalau you tengok sekarang, the dependent variable y duduk dengan dy, independent variable x duduk dengan dx. the different side. This one is your right hand side and this one is your left hand side. So this one is the separable equation. So itu adalah cara on how to separate or check on our equation, either dia adalah separable ataupun non-separable.